Hi, this is Sung again. I'm your online maths mentor and we're going through extension 1, and in this episode or in this chapter we're going through extension 1 trigonometry, which is basically the trigonometry extension to the 2-unit trigonometry, 2-unit mathematics trigonometry that you will have done in the 2-unit course. Okay, so now we're up to episode 6, and in episode 5, remember, we went through the formula for the product, right, of sine and cos as a sum or difference, and now we're going to do the reverse, which is the sum or difference as a product. And like I said, when it comes to doing the product as a sum or difference and the sum or difference as a product, it is optional, okay? It's not something that you have to know, but let me tell you, if you do know it, it can make life a lot easier for some of the harder 3-unit stuff, but also not just for the harder 3-unit stuff. For those of you who are taking extension 2, it will become a lot more handy then as well, okay? So in order to be able to work from a sum or difference to from a sum or difference to a product, rather than from a product or a sum or difference, we're going to start with these formula, right? We're going to start with formulas for the product as a sum or difference. So we're going to start with formulas 1, 2, 3, and 4, and on the right side of the screen, that's exactly what you'll see. You'll see formulas 1, 2, 3, and 4 on the right, okay? So what we're going to do is we're going to start here and work from the sum or the difference. See how this is a difference, and we're going to turn it into a product. We're basically switching this formula around. So the right-hand side becomes the left-hand side, and the left-hand side becomes the right-hand side for that one. All right, and the same for formula 2, 3, and 4. Okay, but what we're going to do is we're going to collapse a plus b into another letter. So let's let a plus b equal u, right? And we're also going to collapse a minus b into another letter, a minus b equal v. So in other words, what we're going to do is we're going to consider the sum or difference, right, as we have it here, and we're going to rearrange that using the letters, or we're going to modify that using the letters u and v, okay? So let's have a look at how that will look. Right, so if a plus b is equal to u and a minus b is equal to v, what you have for these particular formula is this, right? You've got sine u minus sine v, yeah? And for this formula, you've got sine u plus sine v. For this formula, you have cos v plus cos u, which is exactly the same as cos u plus cos v, right? And here we've got cos v minus cos u, and we're also going to consider cos u minus cos v as well, okay? So there we have it. We've got the left-hand sides of all the formula down packed. What we are going to do now is consider how that affects the right-hand side, okay? So let's have a look at this. We remember how we said we're going to let a plus b equal u, and we're going to let a minus b equal v, right? Well, here's what we're going to do. Let's call that equation I, and let's call this equation II. And what will happen when we add I and II, when we add these two equations together, is the b's will cancel out, but we have 2a equaling to u plus v. Does that make sense? Right. So if that's the case, what will a equal to? A will be equal to u plus v on 2. Got it? And that's going to be very important to us. We're going to do the same thing, but instead of adding these two equations together, we're going to subtract. And when we subtract, the a's are going to cancel. Yep. So they're going to cancel, but the b's, the minus, will become a plus. B plus b will give you 2b, and 2b would be equal to u minus v, yeah? Because remember, we're minusing equation 2 from equation 1, which leaves us with b equaling u minus v on 2. Does that make sense? All right, so in other words, every time we see a, we can replace it with u plus v on 2. Every time we see b, we can replace it with u minus v on 2. So this is what we end up with. Let me just explain. Or let me just substitute. What we end up with is 2 cos u plus v on 2 sine u minus v on 2. Got that? And on this side, we end up with this equation here. Now, when it comes to this equation here, what you'll end up with is 2 outside of cos u plus v on 2 cos u minus v on 2. There you have it. All right, and it'll equal the same thing whether it's cos v plus cos u or cos u plus cos v. It'll be the same thing, won't it? When it comes to the fourth equation, cos v minus cos u, which is that one there, will be 2 outside of sine u plus v on 2 sine u minus v on 2. But when we swap these two around, what you'll notice is that this minus becomes a plus and that positive becomes a minus. So this sign has to flip as well. We end up with minus 2 sine u plus v on 2 sine u minus v on 2. And there you have it. You have your 1, 2, 3, 4 formula. You got your 4 formula for sum or difference as a product. Okay, so now we know the compound angle formula for sine, cos and tan for the sum and difference of an angle. We know the double angle formula for sine, cos and tan. We know the product formulas as a sum or difference, and now we know the sum or difference formulas as a product. Thank you very much for watching.